Hello everyone, this is part 3 of the truss joist tension design and continue on example 9.5. So then once we sectioned through this chord here, which is L2, L3, L2, L3 here, we want to design this chord, right? We want to design for this chord and against any type of failure that may come due to this load in the top here. Let me grab my pen. So then this is statics and structures, right? The CM231. We section it through the system here, and we have the effect of these loads. Then that's what we have as L3, another point, but we're going to take a moment here in U2, as you can see in, from the problem statement, from the procedure, excuse me, step number 4 here. We're going to take a moment in U2 and to determine the internal force value of L2, because that's what we're going to design for. So if we're taking the moment at U2, then all the forces equal to 0, like you see here. And you take moment counterclockwise is positive, as we have learned. So this is a clockwise, so 30.96 is 0 times the 2 base distance, which is 6 by 6 at 12, as you see here, plus all the other forces we have. So this one here is counterclockwise, so it's positive times 12. This one is counterclockwise, which is positive times 6, times the force here, which is FL2 L3, and this one also clockwise times 4, which is the distance of vertical distance from here to here, and then we find the force as it to be 61.92 kips. So we will take this value according to the design procedure we went over in the previous lecture and design for it. So then moving on, we use equation number 9.1. If you remember, 9.1 is PU equals 0.9 Fy Ag, which is the gross area. So our attempt here is to find the gross area. We already find the PU, which is 61.92, divided by 0.9 times Fy, which is 50, and it gives me 1.38 inch square. That's the gross area. So we're going to select our section based on the gross area. So then what you need to do is to go to Appendix C. Go to page 448, Appendix C, and select a shape. Now, because we have the gross area is 1.38, if you start actually from page 447 and look over 1, 2, 3, 4, the fourth column from the left, it shows you the area. But all the areas we have here are larger than our gross area, which is 1.38. So we want to choose an area that is less than this, less than the 1.38. So if you go down in the column, the fourth column, the area, everything is larger. Then if you flip the page, you go to 448 page, and you keep going, you reach actually a few other options that is less than 1.38, but we'll follow the book example and we'll choose 1.2 area. And if you cross it over to the left, you go to shape L3 times 2 times 1.4. So this is our shape here, and we'll choose 2 angles. But if we choose 2 angles, then we multiply this area, the 1.2 that we found from the table. Okay, so the area we find in it from the table, the gross area is 1.2 inch squared. Then we multiply it by 2, it gives me 2.4. So now our new gross area is 2.4. This is what we're going to work with because we have a new shape. Now, what is the centroid of this shape? If you, again, flip the page one more time, page 450, and you go to the first column to find the shape, you'll find it. And then if you go across the page, under 1, 2, 3, 4, the fifth column is the X bar column, which is the centroid, and you will find this value, which is 0.487, and that's your X bar. So then the second step is to find the hole size. Now it's giving the problem statement 3/4 the hole size, and then you add 1.8, like we said, to find the hole size, and then we have 7/8 of an inch. Now to find the area net is the area of a gross area, which is what we have found minus 1 hole times the 7/8 of an inch, which is the size hole, times the thickness of the plate, and it gives me 2.18, which is the net area. Then to utilize this equation, which is the X bar U equal 1 minus X bar over L, the X bar is what we have found from appendix L. So the distance from here to here is 6. Now we're taking half here per our section, which means the area from here to here is 3 feet. And then that's what we have. 0.87, that's your U. So to find then the effective area is to multiply the U by the AM. And then our effective area is 1.83 inch squared. So to utilize equation 9.2, which is P equal 0.75 FU AE, is the FU is 65 from table 9.1 times 1.83, which what we have found here. And it gives me a total of 89.27 kips. And this value here is actually larger than the p-value we found, the value of this internal force. Remember, this internal force has actually become compression. Right, if I take you one step back here, see, it's compression. This arrow pointing in or oriented in this direction, that means compression. It's not tension. So then our value here is larger than the actual value that we found in the internal force, so we are good. That means our design is adequate. Now what we have to check for is the black shear trend. Just like we did in example 9.5, if you go to my lectures on the black shear, I will want you to follow the same steps and procedure that we worked on in example 9.5, is to use it for this problem to design to check the black shear and see if it fails in the tensile effect or the rupture effect. Okay, so with that, I'll stop here and we'll continue later on. Thank you.